I do feel that it is worth mentioning what's happening with the hair. I left it wet last night and when I went to get a shower, and that's a mistake. I have regrets. I can't go back in time and dry my hair before I went to bed, and it's almost time to get another shower, but I wanted to knock this out ahead of time. So you're getting unruly, curly-haired Jillian. Deal with it. Okay, so for topic 4, we're going to look at finding equations of parabolas. So in this case, you can obviously see here, for example 3, we're going to look at a graph and pull some information from the graph and then get an equation. In the next examples, we're going to be given information about a parabola and we're going to build the equation from that, okay? So it is worth reminding yourselves of what standard form of these equations look like. So when you're dealing with a parabola that is oriented vertically, we have this equation. It's going to have x minus something squared. And then when we are dealing with a parabola that is oriented horizontally, we're going to have y minus something squared. Okay? Whoops, I just like got really aggressive over here. Okay? So keep that in mind. Vertically opens up and down, we're going to have x squared. Horizontally opens left to right, we're going to have y squared. Okay? So for example 3, it says find the standard form equation for the parabola described below. Okay? So let's notice some stuff here. They've given us 3 really important bits of information. They have given us the vertex. So this is the point 2, -1, and that's the vertex. Okay. They have given us this super duper important point right here, which is 0, -1, and that is the focus. And then they have similarly given us this super important doomiflugy right here. This is the directrix, and it is x equals 4. Okay, so the equation for the directrix, remember the directrix is a fixed line, and its equation would be x equals 4. How do I know that? It's vertical. X equals is always going to be vertical, and we go through this point right here, which is 4, 0. So I know that this is going to have the equation x equals 4. Now, they've also given us some extra bits of info. So right here, let's do blue maybe. So right here, they gave us these 2 points here and here. So we have 3, comma, let's learn how to do a proper ordered pair. We have 0, 3, and then we have 0, -5. So those would be the 2 endpoints of the latus rectum. That's the distance through the focus across the parabola, okay? So we've got some really important information. What do we need? Well, we need to think about what the standard form of the equation would be. Notice here, we're definitely opening to the left. So because we're opening to the left, that means we are horizontally oriented. And that's going to give us y minus k quantity squared equals 4 times a times x minus h. So that's kind of the standard form that we're looking for. So what do we need? We need values for k, we need values for h, and we need values for a. So what do we need? K, a, and h. Let's go ahead and find a. Let's just arbitrarily pick that one. So a, let's talk here. What is a color I have not used yet? There isn't one. Let's just stick with black, I suppose. So this distance here between the vertex and the directrix and between the focus and the vertex, those values are the same and those represent A. Okay, so my focus is, so let's see, we go from 0, -1 to 2, -1. And then we also go to 4, -1 if we were looking at this ordered pair right here. So what do we notice is changing? Well, the x value is changing. So if we find this difference, this consistent difference in the x values, we can figure out what a is. So how do I go from 0 to 2? I add 2. So this would be 0 plus 2. How do I go from 2 to 4? Well, I would add 2. So what am I adding? I'm adding 2, okay? So you can see visually that we have a difference of 2. Okay, so like the distance from the focus to the vertex and then from the vertex to the directrix is 2. Okay, so we can say pretty confidently that A is 2 units. But let's really talk about this. We always have to know if A is positive or if A is negative, okay? And we use this first of all, like if we're given the equation, we use that to just think, hey, is this opening up? Is it opening down? Is it opening left? Is it opening right? Well, we can see without a shadow of a doubt, this parabola is opening left. And if we go back, it's got me all choked up. If we go back to our table of values, we have a parabola that is horizontally oriented. Hold on, let me get a sip of water. And what we really need to make note of is if A is negative, the parabola opens to the left. Okay, so if we go back down here, remember, we definitely have a situation where the parabola is opening left. So this tells me that A has to be -2. So officially, A equals -2 because I have to open to the left, and the way we open to the left is when A is -2. Okay, so we can start filling in what we know. So let's go ahead and say, hey, we know what A is. Let's make it a bright color. Well, let's do this magenta color. So we know that A is -2. We'll clean this up in just a bit. Now, from the vertex, we can get H and K because remember, the vertex equals H comma K. And H is what we subtract from X, and K is what we subtract from Y. So if our vertex is officially 2, -1, okay, that was this point right here that I originally did in magenta. All right, this is 2, -1. That tells me that I'm subtracting 2 from X and I'm subtracting -1 from Y. So let's plug those values in. So let's go up here. We're going to subtract -1 and we're going to subtract 2. Okay, now we technically have enough information at this point to fill in the equation. We were missing K, A, and H. We found values for K, A, and H. So we can now come down here. We can prettify this. We can make it look nice. We have Y minus -1. Well, when I subtract a negative, I just get addition. So I get Y plus 1 squared equals 4 times -2. Well, 4 times -2 is -8. And then X minus 2 is just X minus 2. And that's all she wrote. That's the final equation. So if you're given something like this, you need to find values for X, H, and A, and you're good to go. Okay? Now, before you get ahead of yourself on example 4, I am going to actually do 2 examples here. I wish I had set this up originally to do 2 examples, but like I said earlier, I had kind of printed. I haven't kind of printed. I had already printed when I decided I might want to make a couple of changes, and so this was one of them. So we're going to actually do 2 problems here. The second problem, we're going to have a focus of 4, 0, and a directrix X equals 2. Okay? So, for example 4, it says find the standard equation for the parabola described below. So we have a focus for, let's say this is part A, even though this is an afterthought. We'll say these are parts A and B. So for part A, we have focus is going to be the point 0, 2. The directrix is going to be Y equals -2. So let's kind of just do a quick sketch just to get a visual in our head of what's going on. So we have a situation like this. Y equals -2 is a horizontal line. Okay, so this is our directrix. Okay, we have the point 0, 2, which is our focus. Okay, so when the focus is above the directrix, okay, I know I'm going to have a parabola that's opening up. Okay, remember the focus is always going to be the vertex is going to be halfway between the focus and the directrix. So I'm going to have a situation like this. Okay, so let's see if we can get an equation that goes along with this. All right, so we're opening up. Okay, we go through the origin. we have a directrix, we have a focus, we've got a lot here. So since we're opening up, we're going to have an x minus h quantity squared equals 4 times a times y minus k. Okay, well, my vertex, if it's halfway between the focus and the directrix, it has to be through the origin here. Okay, so the vertex has to be exactly halfway between the focus and the directrix, okay? Because the distance from the vertex to the focus is the same as the distance from the vertex to the directrix. So what is this distance right here? Well, it's 2 units. All right, so this tells me A has to be 2 units, and then we have to ask ourselves, okay, we know A is 2 units, but is it positive or negative 2 units? So when you're dealing with a parabola that opens up, that tells me that A has to be positive. So we would say A is officially positive 2 units. So we can go ahead and fill in A. All right. And then we can fill in H and K because remember, H and K are the coordinates for the vertex. So the vertex is, I should actually go back to black, is H comma K. Remember, H is what we subtract from X. K is what we subtract from Y. And we have that our vertex is 0, 0. So that tells me H equals 0 and K equals 0. So let's plug those in. Whoopsie. There we go. So let's plug in minus 0, minus 0, and then let's just clean this up a little bit. X minus 0 is just X, so I could write that as just X squared. 4 times 2 is 8. Y minus 0 is just Y, so my final equation would be X squared equals 8Y. Okay? Let's do what would technically be part B if I decided to do this before I went to print. Okay, so for funsies, we're going to do the same thing. We're going to find the standard form of a parabola or the standard form of an equation for a parabola. This time we're going to have a focus at 4, 0, and our directrix is going to be x equals 2. So let's kind of just do a quick sketch to get an idea of what's happening here. So this would be my directrix. How do I know this? Because x equals 2 is the directrix. X equals indicates a vertical line through 2 on the x-axis. And then this is my focus. So that tells me, make that a little more obvious. That tells me that my vertex has to be exactly halfway between the directrix and the focus, okay? Because the distance from the vertex to the directrix and the distance from the vertex to the focus, they're the same distance. So my vertex has to be here, okay? So what do we know? We know the directrix is x equals 2. We know the focus right here is 4, 0. And we've got enough information here to find the vertex, okay? So my vertex, well, I'm 1, 2, 3 units from the origin. So that tells me my vertex is 3, comma, and then I don't leave the x-axis, so it's 3, 0. So I now have my vertex, which is 3, 0. Okay, so let's figure out A, and then let's figure out H and K, because remember, we're going to need something like, well, let's first figure out which direction this puppy's going. This, I should have said it already, is opening to the right. Okay, so this is a horizontally oriented parabola opening to the right. Okay, so we know that the standard form of this is going to be y minus k quantity squared equals 4 times a times x minus h. Okay, so let's find a. So this distance from here to here and from here to here, that is A. Okay, so I know from this ordered pair to this ordered pair, that is twice A. So I've got the ordered pair, let's say we're going 0, 2, 0, and then 4, 0. So from 2 to 4 is a distance of 2 units. That's 2 times A. So that tells me A is just going to be 1. So the distance from the directrix to the vertex is 1 unit. They're 1 unit apart. And then from the vertex to the focus, also 1 unit apart. So right now, A is 1 unit. But is it positive or negative? Well, if you kind of go back to those tables in the previous video, we can scroll up just a second. So if we look here, we have a parabola that is definitely horizontally oriented, okay? And we know that if A is positive, the parabola is going to open to the right. And we are definitely opening to the right here, okay? So let's scroll back down. Okay, so that tells me that A is positive 1. So we can go ahead and fill that in to the equation. So times 1. Now let's figure out what H and K are, okay? So remember, the vertex is H comma K. H is what we sub from X. K is what we sub from Y. Our official vertex is 3, 0. So that tells me H is 3, K is 0. Okay, so we can go ahead and replace H and K. So just be really careful. K always goes with Y, H always goes with X. Okay, so we're going to go Y minus 0 and X minus 3. Okay, and then let's just clean it up a little bit. So officially, we're going to get Y minus 0 is just Y. So I get Y squared. 4 times 1 is just 4. Okay. And then X minus 3, we'll just leave it X minus 3. So we get Y squared equals 4 times X minus 3. And that's it. Okay. So that is finding the equation of parabolas given a graph or just given some information. So we specifically have the focus and the directrix, which is really nice because we know the vertex is going to be slam jam between those two. And if we can have the vertex, we can figure out the distance from the vertex to the focus, from the vertex to the directrix. That tells us what A is. And then the vertex is the H and the K. So we have those 3 really important pieces of information that we then have to plug into the formula and simplify. Okay? Now, second to last example, the last example I'm going to do in a separate video just for the sake of time or length of video more so. For example 5, it says, show that the graph of the equation is a parabola, state the vertex, the focus, and the directrix. Okay, so to prove that this is a parabola, we want to make sure we fit one of the 2 formats. So we're looking to fit standard form. X minus h quantity squared equals 4 times a times y minus k, or y minus k quantity squared equals 4a times x minus h. Okay, now what in the world do we have here? We have a lot of work ahead of us. Not really a lot, but we do need to complete the square. Okay, so I definitely see that there's a y squared, and then I see this other y term, and then I see this random x term. So let's see if we can get all of the y's on one side of the equation, everything else on the other side, and then let's complete the square because our goal is to get it into this format of like a binomial type situation where that quantity is squared, okay? And because the y is what's squared here, I want to try to start by completing the square for y, okay? So I'm going to leave y squared minus 6y on the left. I'm going to leave a little space because when we complete the square, we have to add something. And then I'm going to go equals. And then basically what we're going to do here is we're going to add 8x and we're going to subtract 17 from both sides of the equation, okay? So when I subtract them from the left, they just kind of, they don't go away, they cancel, but then they're going to get moved to the right. So the right-hand side is going to be 8x minus 17. And then don't forget, leave a little space because we have to complete the square. And when we complete the square, we add something to both sides of the equation. So to complete the square, we did this in chapter 10, so this shouldn't be totally new to you. When we were talking about polar form of equations, we had to do some, my dog is upset, sorry. We had to go from polar form. Winnie June. She's having a bad dream because she was sound asleep. She must hear something. Hold on. Okay, sincere apologies, a belly rub and a little kiss on the noggin, and she's good to go. Okay, so completing the square. We talked about completing the square in chapter 10, so hopefully this is still kind of fresh. We had this idea of polar equations, And so when we had these polar equations that were circles and we converted them to rectangular form, we would sometimes complete the square. Okay, so hopefully this isn't totally like dead in your mind. It should be fairly fresh. So what we do is we isolate the two variables that are going to be part of this squared part. And we add negative b over 2a. Whoa, don't do that. We add negative, I was getting ready to do the vertex formula. We add b over 2 quantity squared to both sides. Okay, b, we mean the coefficient of the linear term. So in this case, b is negative 6. So we would take negative 6 divided by 2, square it. Well, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So we want to add 9 to both sides of the equation, okay? And the reason we do this, the completing the square, is it forces this to be a perfect square trinomial. And we like that. We like it because of the way it factors, because a perfect square trinomial factors in such a beautiful way. We take the square root of the first term, so the square root of y squared is y. We take the square root of the last term, square root of 9 is 3. And then whatever we have right here, that tells us if we're going to add or subtract in our factored form. So we're going to subtract, and then we're going to take that quantity and square it. So looking right here, we have something that looks very similar to y minus k squared, which is great. So we're definitely getting to that form. Now let's see what else we've got. We have 8x minus 17 plus 9. Well, negative 17 plus 9 is negative 8. So we get 8x minus 8. Okay, so let's see if we can clean this up a little bit more. The y minus 3 quantity squared is great. I don't want to do anything with that. And then 8x minus 8, I could factor out an 8. So I would just get 8 times x minus 1. I can hear her grumbling again. I don't know what's gotten into her. I'm really sorry, you all, but I've got to keep going. Otherwise, I'm going to be up until 2 in the morning. Okay, so we have this format, and this format looks very much like this. Okay. We could even go further. We have this right here, this 8, and we know it has to be the same thing as 4a, so we could very specifically figure out what a is, okay? So if I say, hey, 8 has to equal 4a, well, if I divide both sides by 4, I get that a is equal to 2. So I could rewrite this as y minus 3 quantity squared equals 4 times 2 times x minus 1. And then it is certainly in that format for standard form of a parabola. We don't generally write the 4 separate from the 2. We would simplify them, but just to prove that we're definitely in that right format with 4 times some constant a times x minus h, we're there, okay? So this problem says state the vertex, the focus, and the directrix. Well, the vertex is pretty easy. Remember, vertex is always going to be of the form hk, where h is what we subtract from x, and k is what we subtract from y. Okay, so that would tell me that my vertex is very officially what I subtract from x was 1, and what I subtract from y was 3. So my vertex is 1, 3. Okay, now we also have to find the focus. Okay, so the focus, it is sometimes helpful if you can kind of envision sort of like just a sketch of the graph, like nothing crazy, just a general sketch. Okay, so we have the form y squared. So this is definitely going to be a situation where we have a parabola opening left or right. And because we found that a was 2, we can say this is a parabola that opens definitely to the right. Okay, so just as kind of like a real simple sketch. Okay, this is a parabola that opens to the right, and it has a vertex 1, 3. Oh, I hear it now. My dog heard there's like sirens outside. That's what she was barking at. I hear it now. So we have a parabola that's doing something like this, okay? And this is definitely just a sketch. It's nothing formal, okay? Now, what we do know is that the directrix and the focus are going to be a units away from the vertex, one to the left, one to the right, okay? And we know that a is 2. Okay, so if my vertex is here, I need to go 2 units to the right to get to my focus, and I need to go, well, I went a little dramatic there. Let me go a little. I need to go 2 units to the right to get to my focus and 2 units to the left to get to the directrix. Okay, so what is the focus? Well, I need to take whatever my H value is. My X's are what's going to change. Okay, I need to take H and I'm going to add A, and then K is going to stay exactly the same. So this is going to be, well, H is 1 plus A, which is 2, and then K is just going to stay K, so it's going to be 3. So 1 plus 2 is 3. So my focus is the ordered pair 3, comma 3. Okay, so this would be the point 3, 3. Now for the directrix. So the directrix is always going to be on the opposite side of the vertex as the focus. So if I add A units, I need to subtract A units to get to the other side of the vertex. So basically what we do here is I need my X value to change, my Y value is going to stay the same. So if I can find this ordered pair, I can figure out the point that my directrix is going to go through. And then we kind of find the ordered pair and then we use it to get the equation for the directrix. So I need to basically subtract A units. So it's going to be H minus A, K. So that's going to be 1 minus 2, 3. So my directrix is going to go through the ordered pair, -1, 3. Did I do that right? Where's my vertex? Yeah, so I was a little off here. My drawing is a little crappy. Let me fix my drawing. There. So my directrix is going to go through this point right here, which we know is -1, 3. Okay, but the directrix it's a line, it's a fixed line. So we need the equation of a line. So we want the vertical line that goes through this point. So officially my directrix is going to be X equals -1. And that's it. So we got the equation, standard form right here. I was about to do a star. We got our vertex, we got our focus, we got our directrix, and we didn't have to, we didn't have to list A, but we had to find A to find the other points. So there you have it. That's our equation. That's our vertex, our directrix, and our focus. Okay. One more example in another video, and it's going to be an application.